Everybody tell now.
सर एक्चुअली लेक्चर नहीं देख सके, वो हम नमाज पढ़ने के लिए चले गए थे। मे बी लेटर ऑन हम देख लें उसको।
Anyone else who has listened to this? Okay, is this slide visible to you now, which is I'm sharing with you?
Yes, sir.
So, okay, talking about the self-compacting concrete, this is the concrete which can, you can say, compact itself without any kind of external effort. The standard regarding this, which we use, that is EF NOC, which normally deal with this development or the science, and ACI is also there. ACI Committee Report 237 is there, which deal with the self-consolidating concrete. It is defined as which is highly flowable, non-segregating concrete, which can spread into place, fill the formwork, go into the reinforcement without any mechanical consolidation. You don't need any mechanical effort. This is the definition by ACI 237 report. However, talking about ASTM subcommittee report, it says that concrete that can flow around reinforcement and consolidate in the formwork under its own weight without any additional effort while retaining its homogeneity. These two definitions are there by the ACI and ASTM, but you can say that any concrete which is self-flowing, you don't need any kind of external effort to make it flow or compact. That is called as self-compacting concrete or self-consolidating concrete. Are we clear? Students, are we clear?
यस सर।
सो ऐसा कंक्रीट जिसमें आपको कोई एफर्ट ना पुट करना पड़े, जो खुद ही कंसोलिडेट हो जाए, उसे आप सेल्फ कंपैक्टिंग कंक्रीट कहेंगे. Okay. What is the difference between self-compacting concrete? So the self-compacting concrete has three characteristics. Its number one is its flowability. Number two is its passability through the reinforcement. And number three is its stability, that there is no bleeding or segregation. So these three things are there. Normally self-compacting concrete is highly fluid and it is consistent like honey. So you can say that a self-compacting concrete can be classified as that, which can fulfill these three conditions in fresh state. It is flowable, it is passable, and it is stable. That there is no bleeding or segregation. Then you can say name it as self-compacting or self-consolidating concrete. Now we talk about fluidity and consistency. There is a term that is called as rheology. The rheology means how easily concrete can flow or how much effort you need the concrete to make it flow. So you see with this plastic viscosity and yield stress, the self-compacting concrete is highly viscous or plastically flowable without any kind of yield stress. Normal concrete needs more effort to make it viscous or flowable. However, high strength concrete or flowing concrete still have lesser viscosity or flow. However, in case of self-compacting concrete, they are highly viscous and they have the plastic flow. So what is yield stress? Yield stress is actually force required to start the concrete to flow. That how much force you need the concrete to start its flow. And plastic viscosity means concrete's resistance to flow under any external force. So how you are applying the force and how concrete is flowing, that is called as elastic viscosity. So we see that these concretes, which are called as self-compacting concrete, they are fluid like, they are more like honey. So you don't need any kind of effort to make them flow. So this is the same graph with the colors actually. Now, can you tell me how to make the concrete flowable, passable, and stable without going into the or increasing its water to cement ratio? How we can make it flowable concrete? Very right. We can use different kind of admixtures which can be used as a high range water reducing admixtures, HRWR we name them. This is the real name. You can name it as high range water reducing admixtures. So these high range water reducing admixtures, they can be any by Sika, by BASF, by any chemical industry, but they are used to make the concrete flowable with lesser water to cement ratio. So how these chemical admixtures work, can you comment on to it? Because we are not increasing the amount of water content. So water content is same. So then what is the phenomena which is making the concrete flowable? Anyone who can comment on it? My question is that how chemical admixtures work and make the concrete flowable without any increase of water content. You are not adding any water to it. Then how you increase the workability? How these chemical admixtures increase the workability?
सर इसके अंदर एडमिक्सचर जो हैं वो हम उनको यूज करते हैं, वो चार्ज खत्म कर देते हैं जो सीमेंट पार्टिकल्स हैं उनके ऊपर से, तो उसकी वजह से ज्यादा वो वर्केबल बन जाते हैं।
Hello, students, can you hear me? Students, can you hear me?
Yes, sir. Audible.
Okay. So if you see this slide, how this mechanism is working. So this negative charge apparently being created by the carboxylic ether. So what it does actually, it creates the electrostatic repulsion right at the outer part, whether you are using galenium or you Sicaman, whatever is there. So this electrostatic repulsion will create a mechanism of the steric repulsion or dispersion. So which will keep the system as a flowable, although you have very low water to cement ratio. So you can have a fluidity with lesser water content. This is what is the beauty of this particular system is actually. Are we clear? Now there are also other kinds of admixtures. Once you don't increase the water to cement ratio, so there may be a possibility that your paste volume is low. So once your paste volume is low, what are the chances that your aggregate content will be higher, paste volume will be lower, so you will not get a thick mixture. You may have a very high volume of aggregates, low volume of paste, and your system will not flow properly. So again, the problem in the self-compacting concrete, it seems that it should be consistent as well. Consistent means it should be consistent like honey. So what we use in this case, we use VMA. What is VMA? Viscosity modifying agents are being used in this mixtures. So what is this mechanism? It is also a gel-like which can retain water by absorption or swelling. So this is a mixture. Once you add the water into it, it can have a gel network. This gel network is more like a polymeric, something like this over here. And this gel will give you the apparent picture of the mixture like this mixture is more consistent. This is how we see this gel formation. Are we clear? So two types of admixtures are used in self-compacting concrete. Number one is high range water reducing, and number two, we use viscosity modifying agents. Are we clear? So if you see over here this schematic diagram, if you see the mechanism, so what happens over here, there is a settlement of larger diaggregates than smaller fine aggregate than water. But once we add the VEMA, this viscosity modifying agent over there, what happens, it make it a homogeneous mixture, that it mobilizes it, all the aggregates, all the fine aggregates are being well dispersed into the system. So this is the beauty of this VMA, how it is increasing the fluidity and you can say gel formation of the structure. Now if we compare self-compacting concrete with the regular admixture or regular concrete mix design, so in normal concrete, how much is the percentage of coarse aggregate is there in normal concrete? Can anybody tell?
Normally, sir, 2 times of cement, 4 times of cement, coarse aggregate, and 2 times of fine aggregate.
So you ask that what is the percentage by volume that aggregates are there in the concrete? How much percentage is there?
Uh, 50% coarse aggregate.
50% aggregate is there.
Yeah.
Okay. So normally we have 50% or about 60 to 70% of the total aggregate, where
Yes,
coarse
sir.
and fine both are there.
Yes, sir.
Coarse and fine, they are 60 to 70%. But in case of self-compacting concrete, we have lesser amount of coarse aggregate, whereas fine aggregate is slightly increased. We have normally 30 to 35% of coarse aggregate. The rest 30 to 35% is our fine aggregate. So what does it mean? We are increasing the paste volume in the self-compacting concrete. Are we clear?
Yes, sir.
So rather than increasing the any other thing which is the main parameter which is governing the flowability, there we have more fines in the self-compacting concrete. So in fine aggregate is if there is about 25% in the normal concrete. In case of self-compacting concrete, it ranges between 30 to 40% sometimes. So if we see over here, our coarse aggregate to fine aggregate ratio is normally 1 to 2 in case of normal aggregate. Whereas in case of coarse self-compacting concrete, it is almost 1:1. As much is the fine aggregate, as much is the coarse aggregate. So they both almost their ratio is same. This is the crux of, you can say, self-compacting concrete mix design. Are we clear?
Yes, sir.
So if somebody asks you what is the major mix design difference between the self-compacting concrete and normal concrete, so you can easily characterize by the mix design that this is the coarse volume of or volume of coarse aggregate is being reduced in case of self-compacting concrete. Are we clear?
Yes, sir.
So second thing, what we do, we have reduced water to cement ratio is there. We use super plasticizer in it, and limited coarse content, aggregate content is there. So these are the three major, you can say, parameters are there. And then we reduce the segregation and deformability. That this means that stability is the primary parameter, that your mix should not be in any kind, it shouldn't be unstable. So are we clear, students? Students, are we clear?
Yes, sir. Yes, sir.
So have you, this is the major, you can say, I have discussed with you initially the definition of this self-compacting concrete, what are chemical admixtures, how they perform, what is VMA, what is the mix design, how it proceeds. So next is, what is the advantage or significance of it? The major significance of self-compacting concrete is its porability. That you don't need any kind of tamping rod, any kind of labor. You don't need any kind of thing. Just you need no need of vibration, nothing you need. Just you need a concrete dumping pipe. It will fill all the side by just one pipe, something like this. You see on the slide. You don't need any kind of labor. If you see as what is the volume of the site, and you don't see any kind of labor over there. Just there is a one mixing concrete truck is there, and then there's a pipeline which is spreading the concrete. This is the major advantage of self-consolidating concrete. Are we clear?
Yes, sir.
So now talking about the cost effectiveness, although its initial cost is high, but if we see its labor cost, the overall cost of self-compacting concrete is about 92.5. However, our conventional concrete costs us 100%. So it means we can save huge amount of cost by using self-compacting concrete. So this whole credit goes to Professor Okamura, who is the father of this invention, who developed this concrete back in 80s. He got this idea by the mud flooding, actually. He got this idea by the mud flood. That mud flood goes everywhere and then settles and very solidify everywhere. So he said, then why not to develop a concrete which can go everywhere and then which can consolidate everywhere. So he said that through this we can reduce the labor cost, and then you now see how many people have done PhDs, and it's now almost already a commercially available material now. Are we clear, Ji? So all is about regarding the significance. Then comes the chemical admixtures. Chemical admixtures are three kinds of there. There are three generations of chemical admixtures. Number one is sulfonated melamine formaldehyde, then sulfonated naphthalene formaldehyde, and the third one is nowadays which is normally used, that is polyether polycarboxylate based. Third generations are there. This is what we normally nowadays use in the market. PCE based. These are called polycarboxylate based, ether based. So these are high range water reducing admixtures. Then there are viscosity modifying agents are there. So I have discussed them, how they develop, what is the mechanism behind them. This already we have discussed, isn't it? Student, is it clear to you?
Yes, sir.
Students, is it clear to you, beta, or not?
Yes, sir, it is clear.
So I'm going to share these slides with you. So then comes its testing. So then these slides are regarding the practically available projects which people have used internationally. The world is doing work on it. We are unable to know. Maybe one of you was telling that on some project they are trying to develop this concrete. I don't know it is being developed or not. Is it or not? कौन बता रहा था अभी कि किसी प्रोजेक्ट पे यूज कर रहे हैं? तो वहां पे आप सेल्फ कंपैक्टिंग कंक्रीट यूज कर रहे हैं. So I would love कि अगर आप उसकी कोई प्रैक्टिकल कास्टिंग की कोई वीडियो बना के हमारे साथ शेयर कर सकें स्टूडेंट्स के साथ क्लास में. So you are a PhD student, I think, isn't it? So that's nice. Very nice. So this is maybe first time I'm listening somebody is making this self-compacting concrete in Pakistan. So very good, very interesting. All that it reduces a lot of cost. So the talking about the tests. So their testing is slightly different than the normal test. If we go for the normal concrete, we have this slump cone test, isn't it? ये नॉर्मल टेस्ट आपके पास कौन सा स्टैंडर्ड है जी? ASTM C143. और इन दिस के but over here you measure the flow, there how much is the flow diameter is there. So here we are concerned with the D1, D2, D3. What are the diameters of spread? कि कंक्रीट स्प्रेड कितना किया और उसमें सेग्रीगेशन तो नहीं है या ब्लीडिंग तो नहीं है. दिस इज द कंसर्न फॉर एज अ इंजीनियर्स विद अस. So we measure that this is T500 diameter. The diameter of this hole is 500 millimeters. So we see that how much is spread. So ये इससे बाहर कितना गया है? 650 से ज़्यादा है, 650 से कम है. So there is a range. Then we see that where it is retained, and what diameter it has retained its shape. So this is one test, slump flow test is there. Second one is ring test. So we have reinforcement, and through reinforcements we see that how much concrete has passed. So how much it has passed. It is ASTM C1621 is there. So these are the mostly two common tests. I don't know this is being used in the market or not. The guy can tell you on this. जी बेटा ये कर रहे हैं आप ये टेस्ट के ये सिर्फ यही कर रहे हैं आप. So this, in this case, you see there how much the concrete is passing through the reinforcement. This gives you the timeline that what is the possibility through the, if there is a rear reinforcement. This is simulating the reinforcement actually. Clear? So this will tell you that either it is a flowable or not, it is blocking assessment is there or not. So you can see there is a criteria actually. So you can, through this criteria, you can define that either your slump flow is class C SF1 starting from 500 to 700, 642. So with the different diameter range, you have different slump flow. So same is with the V funnel test class as well. This is being defined by EF0 standard. Right at the start in the very first slide, I told you these criteria is by EF0 05. They are defining it actually. So this V funnel, this last one, so you fill it and then you open it and then you see how much time it is taking to get it empty. Kitna time leta hai ye empty hone mein. So that time is being defined as 10 seconds, 7 seconds, 27 seconds, 3 seconds, how much time it is taking. So accordingly, we define that this is class VF1, VF2 accordingly. So you define, so these all are the tests which regarding the, so these are the 4 different kinds of, you can say, shapes of concrete you can see over there. So you see this is homogeneous, no any kind of water on the sides. Here you have a complete water sheen. You see shining sides over there, water is coming over there. Then you see the bleeding is there. Surface we have a concrete small bleeding. Here we have segregation right in the middle. So these 3 are not desirable. We need a homogeneous, well consistent, without any kind of bleeding. We need this kind of concrete. Otherwise, we can compromise on the strength or other characteristics. Are we clear? So this also has been defined by somebody that he said that visual stability index. That you just see the mixture and then you can define that it is workable or it is usable or not. We should use it or not. How to define it, how to take it. Are we clear? So these are some tests regarding this. So now I'll share the slides with you in the group now. So you can go through them. And if you have any problem, I'll be online. We can discuss on it. Okay. Hello students, I have shared the slides. I have shared one lecture as well. So both you can go through and then right after 20 minutes, we can discuss on it. If there is any question, we can please go through them. If you have any questions, we can have a discussion on that. Are we clear?
Okay, sir.
Please read it.